All right, so now we're going to focus on more of what the SOL is going to ask you questions about, which has to do with the z-scores and the normal curves and the standard deviations. So if we have a symmetric distribution and wanted to find out how many standard deviations a certain observation was from the mean, we would simply calculate its distance from the mean and then divide it by its standard deviation. So the standardized value is what we call a z-score of an observation. And so what you do is you take the observation, subtract the mean, get that answer, and then divide that by the standard deviation, which you got already. So if we wanted to take a set of 5, 10, 20, 65, and 80, so the mean of that would be 36. The standard deviation is going to be 34.17. So if we wanted to know what the z-score for 5 would be, you would say 5, because that's the observation we're working with, minus the mean, which was 36, and then that would be negative 31. And then we would divide that by 34.17, and that would give you a z-score of negative 0.91. So in other words, the observation 5 is slightly less than 1 standard deviation below, I'm missing some words here, hold on, below the mean. Okay, when we standardize data into z-scores, we are shifting them by the mean and rescaling them according to their standard deviation. This way, no matter what the units of our variables were, the units become generic. So the standard normal, and then it becomes symmetric. Okay, so the first thing you need to understand about a normal curve is the 68, 95, 99.7 rule. Remember that the interquartile range gives us the middle 50% of the data, and that says that we have a normal distribution would have 68% of the observations fall within 1 standard deviation of the mean. 95% of the observations would fall within 2 standard deviations of the mean, and 99.7% of the observations would fall within 3 standard deviations of the mean. So the standard normal would look like this. The mean would be at the highest point here in the middle. 1 standard deviation to the left and 1 standard deviation to the right would satisfy 68%. So that's 34 to the left and 34 to the right. 2 standard deviations either way, and that accounts for 95% of the data. And then 3 standard deviations either way would account for 99.7% of the data. So the empirical rule is what we call it. It's 68, 95, 99.7. Okay, so if you broke that down from the mean, it's 34, 13.5, and 2.35 on each side. So how much does that leave in the tails? 0.3%, which you have to split with each tail, gives you 0.15% in each side. So when the value doesn't fall exactly 1, 2, or 3 standard deviations for the mean, that's when you have to use your z-table, which the SOL is going to provide a z-table for you, an actual z-table, or it's just as easy just to use your graphing calculator. Okay, so suppose a normal, so it has to state that it's normal in the problem, model describes the fuel efficiency of a car currently registered in your state. So the mean fuel efficiency of the car is 24 miles per hour, and it has a standard deviation of 6 miles per gallon. So that's where these numbers came from. 24 is representing the mean, and then because the standard deviation is 6, 1 standard deviation would add 6, gives you 30, add 6, would give you 36. Add 6 would give you 42. So 1 standard deviation, 2 standard deviations, 3 standard deviations. From the mean, take away 6, take away 6, take away 6. Okay? So using our empirical rule, we could say that 68% of the cars are going to get between 18 and 30 miles per gallon. Because remember, that 68% of our data is going to fall within 1 standard deviation on either side of the mean. So what percent of all cars get less than 15? Well, the problem is, if you remember, 15 wasn't one of those numbers. 12 and 18 were. So how are you going to figure out 15? So that's where your z-score is going to come in. 15 is the data you want minus the mean divided by the standard deviation gives you a z-score of negative 1.5. So if you can either use your z-table or you can use on your calculator, let me pull up your calculator, the normal CDF command. Okay. And since we want to know what percent of all of our cars get less than 15, we're going to head back, waiting on the calculator, sorry. Okay. On your home screen, okay, you can get your normal CDF. We go second and the VARS button, and you'll get this menu, and you want choice 2. All right, and then you're going to type in the lower. Since we're looking for the data below, you can go second, VARS, to find your normal CDF. Now, I have one of the newer systems, which allows me to type it in this way. If you don't see it this way, then you'll just see it open parentheses like you will in just a second. So since I'm looking for the data below the 15 miles per gallon, I'm gonna go negative 99. It just needs to be a small number. So I usually either use negative 99 or positive 99. Some people will tell you use negative 999 to positive 999. But it really doesn't affect the answer once you get to that point. So that's my low. My upper was my z-score, which was a negative 1.5. Your mean now is going to be 0 because remember we're standardizing this and your standard deviation is going to be 1. So you want 0, 1. If you don't have the new system, then this is what you're going to just see. Let me back it up. You would have seen the normal CDF. It would have automatically opened the parentheses. You would just type in negative 99, comma, negative 1.5, comma 0, comma 1. And this is going to give you a decimal answer. So this says 0.0668, which you know to change from a decimal to a percent, you move the decimal place over 2 places. So you would say 6.68% would be your answer. So 6.68% of the cars get less than 15 miles per gallon. Okay, so here it is in the calculator. Second distribution, normal CDF, and you can type it in that way. Some calculators, depending on the system, are going to require the comma 0, comma 1. Some of the older calculators let you just type in the low and the high. So 6.7% of the cars are going to get less than 15 miles per gallon. So if you were to ask yourself what percent of the cars get between 20 and 30 miles per gallon, you have to get a z-score for 20 and a z-score for 30, and then you would do your normal CDF between negative 6.7 and 1, and you would get as a final answer 0.0, no, you would get 0.59, which you would change into a percent, which is 59% of the cars are getting between 20 and 30 miles per gallon. What percent are going to get more than 40? Get your z-score for 40. Since you want more than, you're going to type in your z-score comma 99. So your low would be the z-score, and you're aiming to go up from that. And that's why we're going to use the 99. And so that's going to be a very small amount. You know, we've seen the smart cars. There aren't too many of them out there. And so it's a small percent that are actually going to be able to get a higher than 40 miles per gallon gas mileage. Now when you're doing under 20, you got to get your z-score, but see, since you want it below, your low is going to be the negative 99 and your high is going to be the z-score. And so when you type that in, the calculator will give you 0.2514, which is about 25.1%, have less than 20 miles per gallon. Okay, so what you're going to do now is practice some of these on your own. So if you can pause the video and give yourself a chance to work it out, and then I'll work it out after. But it would help you to go through it by yourself once. So at the Illinois Corporation located in Chicago, the ages of all new employees hired during the last 5 years are normally distributed. The problem has to state that they are normally distributed. Within this curve, 95% of the ages are centered about the mean, are between 24.6 and 37.4 years. Find the mean and the standard deviation. So here's my mean. There's one standard deviation on either side. Here's two standard deviations on each side. 3. So we're looking for this. We know this is 68%. We know two standard deviations is 95%, which coincidentally is the number they asked us to look for. So we know this guy is going to be 24.6, and this guy is going to be 37.4. And that's going to cover 1, 2, 3, 4 standard deviations. So 37.4 minus 24.6 gives us 2.8, 12.8, okay? And then we're going to divide that by, these things are equally distributed. So we're going to divide 4 into that because there are 4 standard deviations, and that's going to give us 3.2. So that means there's 3.2 here, 3.2 here, 3.2 here, and 3.2 here. Okay, so if I wanted to know what my mean was, I could add 6.4 and I would get 31. And I should be able to add 6.4 to 31 and get 37.4. So the mean would be 31. The amount of time Finn plays video games in any given week is normally distributed. Remember, I told you it has to say that. If Finn plays video games an average of 15 hours per week with a standard deviation of 3 hours, what is the probability of playing video games between 15 and 18? So let's see if that works out nicely, if we're going to have to run a z-score on that. Okay, so we were told the average, which is our mean, that guy goes in the middle, and we were told our standard deviation is 3. So we're going to add 3, that gives us 18. We're going to add 3, 21, 24, and we can go back, and you're going to get 12, 9, and 6. And we want to know what's the probability of falling. Now look, this one works out nicely. Those numbers they're asking me for are already on there, and we know that one standard deviation to the right is 34%. So the answer to this would be 34%. Remember, that's based off of the 68, 95, 99.7 rule. Okay, the lifetime of a battery is normally distributed with a mean life of 40 hours and a standard deviation of 1.2. So that would make this 41.2, 42.4, 43.6, to 6. Of course, we can come back with it too, but that's not what the question's asking. Find the probability that a randomly select battery is going to last longer than 42 hours. So we're looking for this in here. So because the number you're looking for, 42, does not fall where we want it to, we need to get a z-score for it. So our z-score is going to be the number we want, 42, minus our mean, 40, divided by our standard deviation, 1.2. So that's 2 divided by 1.2. Now I'm going to go to my calculator, and I'm going to do the normal CDF. And my low is going to be my z-score. And I'm going to go up to 99. And depending upon your calculator, you may have to put in the comma 0, comma 1. And that'll tell me the percent. So let me try that. Bring up my calculator. All right. And when I do that, the normal CDF comes up as 0.0477, which is going to be 4.77%, which makes sense. I mean, you're way down here at this end. We know that the majority of it's going to fall in first 2 standard deviations, so that seems like a reasonable answer. All right. All right, so you've had some chance to practice that. Now we're going to have you work some of these on your own as your classwork assignment.